Hello everyone, we are from Team 19. Today we are going to present you with our Gumball project Space Gumball. Continuing from the sprint 1, the sprint 2 we started by playing the planning poker game. We listed all the activities and we did an effort estimation, and based on the outcome we filled in our task board. Here is our task board where we assigned each of the activity to our team members, and from week 1 to week 4 we met on a weekly basis and filled in the number of hours of efforts we put, and also discussed about any roadblocks we had. Here is our burn down chart which is complete. Here is our Kanban task board where we have now set all the tasks that we had to do in the sprint 2 to complete it. Now we will show you a demo of our Gumball project. Hi, I'm going to talk about the strategy pattern that I have implemented in the chase camera. For strategy pattern defines an interface that is common to all different strategies. So basically, using strategy pattern, we can change the behavior at the runtime. In my strategy pattern for custom chase camera, which is the client, I have used two strategies. One is the y-axis strategy, and the other one is the not y-axis strategy. There is an interface axis strategy, which implements a boolean to check whether the vertical y-axis is true or not.
Hi, I'm Asta, and I will be talking about the different states that the game can be in, and also the iterator design pattern which I implemented. There are four states that the game is in. That is the start screen, gameplay, world, and the character moving state. The start screen state is basically the integration with Nifty and the menu in the beginning. The world state is rendering of the world, the different elements that belong to the world. The character moving state is the rendering of our character onto the screen, which is where the iterator pattern has been implemented. As you can see, I used the iterator pattern to implement rendering of the character himself. The iterator loops through the different colors that the character has, and it assigns them to the material, which is then assigned to the geometry itself. Here is the class diagram for the iterator pattern. It consists of the concrete iterator, and which implements the interface, the concrete aggregate, which implements the interface aggregate, and also the character moving state, which is the client.
Hi, I'm Neeti from Team 19. I'll be talking about the chase camera and audio implementations that we have done for our project Space Gumball. Firstly, in chase camera, based on the game status, the camera focus is set to the active node. The chase camera is linked with the mouse keys to turn left and right accordingly, like whatever the user enters. Also scrolling in and out for zooming and rotate based on the mouse movement. So this is what we've implemented for the chase camera part. I have implemented the observer pattern for the coin sound. Here world is the subject and coin sound is the observer. In the world, when character and coin collides, the coin capture sound is played. Coin sound, which is the observer, listens to the world and plays this sound when the collision occurs. Coin sound observer is the interface which is being implemented by the concrete coin sound subject, and the other interface is the coin sound subject, which is being implemented by concrete coin sound subject. So this is the class diagram for the observer pattern for coin sound. So let's look at how it is being implemented in our project. This is the output.
Hi, I am from Team 19 Surabhi. This is our start screen where we have used Nifty GUI. Nifty GUI is a Java library that supports the building of interactive user interface for the games. So here in the start screen XML, we have used the code for starting the game and loading the game. So basically the Nifty GUI is for the user interaction, and here we have taken the scene. In this we have used all the terrains, landscapes and the water and the light scening. Using all those we have created a scene which is similar to the Mars. We have taken the theme as Mars. So let's enter the game. So we'll press the enter. For this loading also we have used the Nifty GUI. So this is our scene which includes all the water, the terrain and the path what the character is walking on, and the lightning whatever is the. Thank you. Here I have implemented observer pattern. I have taken the subject as a character that is moving around the world, which I have given the name collision character subject, which includes all other methods. And here the observer I have taken is the world, which includes the terrain wall, which I have given the name collision character observer, which includes the following methods. So we have collision character subject interface and collision character observer interface, in which concrete collision character subject implements the collision character subject, and the concrete collision character observer will implement collision character observer, and collision subject is extending the concrete collision character subject, and the collision observer is extending the class concrete collision character observer. So let's get into the world. So here when the subject, that is the character, hits the wall, the observer, that is the terrain wall, it notifies it and it replies that it bounces the character back.
Hi, my name is Anand from Team 19, and I worked on the characters in this Gumball machine game. Here I implement the chain of responsibility design pattern, which contains the Gumball machine, Gumball color handler, and three color handlers, which are the blue handler, green handler, and the pink handler, which the Gumball color handler decides on which Gumball is to be produced when the Gumball machine is cranked. Basically, the chain of responsibility design pattern simplifies object interconnections, and it helps give Gumball Color Handler an easier way to choose one of the colored gumballs using a random set of numbers from 1 to 3. So this is how I implement the chain of responsibility design pattern into our Gumball machine game. So I basically concentrated on the characters, the animation, and integrated along with the others. Here is the Blender version that I used, Blender 2.71. It was a daunting task creating the root bones to the animations and the characters and importing them to JMonkey, but we did our best. So here are some of the Blender files that I've been using on. This was the first Gumball machine. This is how I modified it. And this is what we ended up with. So this is how it's rendered to be, which is translated onto the Gumball machine game. I also worked on a few characters, created them. This is the Blender coin that I used. This was borrowed upon from free Blender 3D models. This was modeled by me to say that you have to press the key C to crank and get the gumball. The gumball machine itself was modeled by me. Here's one of the characters that I modeled, created. I would like to display this as it's no longer being used. So here is a look at how it works. That's the walk pose and the stand pose together. Well, unfortunately, since there was a lot of issues with importing this onto JMonkey engine, we had to scrap this model. So there isn't much of information regarding how we can export this model onto JMonkey successfully, because it just distorts the entire image and the model. So we ended up borrowing a character called Quiet Man, that's what we call him at least, from a known artist called Gaston Lagaffe. And thanks to him, we have this character sliding along the icy path in the JMonkey game. So the way we export this is through Ogre 3D Scene and Mesh. As somebody explained in the previous Sprint 1 videos, that it is deviating from the topic of learning design patterns. We don't have to concentrate much on the animation. So we finally ended up with the JMonkey game having the character under models, under Quiet Man, and here's our guy. So when we try to animate this dude, this is what happens. So in spite of all this, we have managed to deliver a working model of the Gumball game, and I'm proud to say that our team did a good job.